Hello everyone, my name is Vipra Joshi and I am an assistant professor in St. Andrews Institute of Technology and Management in Electrical Engineering Department. Today I am going to deliver a lecture on subject of transmission and distribution. In this video, I will be explaining corona, critical voltage of corona, power loss and reduction in loss. This is unit 4th topic of 4th semester in electrical engineering branch. What is corona? It has been observed that if the spacing between the two conductors is less than their the diameter, and if the applied potential between them is gradually increased, a violet glow occurs around the conductor. Here you can see this type of violet glow. Okay, so it occur around the conductor along with a hissing sound at the center value of the potential. This phenomena known as the corona. And the conductor have air gap between them, so air act as a dielectric medium for the conductor, but the dielectric strength of the conductor means the dielectric strength of the air at the normal temperature and pressure is the 30 kilovolt per centimeter. It is used as a dielectric at the voltage for the conductors. But when the voltage is greater than this, so what happen? We see it. Suppose we have a two conductor. Okay, so they are separate between distance d in the air. Air is not a perfect dielectric and not a perfect insulation, we can say. So even in the normal condition, air has a lot of free ions and electrons. Now these electrode, if we say these electrode carry 25 kilovolt. Okay, these electrode carrying 25 kilovolt, we can say it carrying a electricity. So each electrode will generate its own magnetic field like this. Okay, so now the number of free electron in the air will acquire motion and they start to maintaining very a small current. Now the current is almost negligible if the electric field intensity is less than 30 volt per centimeter. Here you can see the value of this 30 kilovolt per centimeter. So this current we can neglect if the electric field intensity is less than 30 kilovolt per centimeter. Then the current flowing between the two conductor is negligible and we can ignore it. But what happen when we increase the voltage from the 25 kilovolt to 45 kilovolt? Okay, now when we increase the voltage from 25 kilovolt to 45 kilovolt, then the electric field intensity between the two electrode will be increased. It is about to 40 kilovolt per centimeter. Okay, so this is the enough to break the insulation properties of the air. So the air will be lose its insulation property and complete a electric breakdown occurs in the air. We can say a arc will be there. Here we have a arc between the two conductor. Okay, so the air lose its property and complete breakdown occur, and arc will be there between the two electrodes, and we can say two conductor. Okay, so same things happens with the transmission line, which carry high and extra high voltage, but the only difference between there is the distance between the two conductor is more in the transmission line. When the conductor carrying a high voltage, then the air surrounding the conductor become ionized. Okay, so when the conductor carrying a high voltage and air surrounding it is ionized, then due to the electric field around it, okay, so intensity of the conductor is maximum at the surface of the conductor, and if we move away from the conductor it decrease. We can understand it by an example. If we have a magnet and a metal clip, suppose, okay, so as you brings to near the magnet by a metal clip, you will feel more force, more magnetic force. Okay, and as you take it the metal clip away from the magnet, the force will be decreases. So here the same case in the transmission line, the intensity is maximum at the surface, and as you move away from the conductor it keep on the decreasing. So we can say the intensity is maximum at the surface of the conductor. So as the intensity at the surface of conductor is maximum, the air near to the surface will become ionized due to the electrical potential of the conductor. So the air is come contact with this electrical potential and it become the ionized. And if the intensity is high enough, and because of this a breakdown occur of the air, and we can say a violet glow will appears along the transmission line, and at the same time a hissing sound, and we can say a hissing noise will be heard, and this is the corona in the electrical engineering. Here the phenomena of the violet glow and hissing noise and production of the ozone gas in an overhead transmission line is known as corona. Okay, so the corona effects occur effectively. The two factors are prime importance as mentioned below. The first is alternating electric potential must be supplied across the line, and the spacing of the conductor. So if the intensity of the line and of the conductor is increasing, then the glow and the noise is also increasing until the spark over the take place. If the surface of the conductor is not smooth, okay, we take a rough conductor and we don't take a smooth conductor, then the corona effect is more. The voltage value at which the breakdown of the air happens at the corona is known as the critical voltage. Corona effect is generally seen in the lines carrying a 245 kilovolt or higher than this voltage. Okay, so phenomena of the corona, this breakdown accompanied by the following phenomena: hissing sound, is produced, a violet glow appears. Okay, so production of ozone gas by the corona and radio interference occur by the corona, and there is a loss in the power. Now, what are the factor affecting to the corona? It is atmospheric factor, field around the conductor, conductor size, spacing between the conductor, and number of conductor per phase, and profile of conductor, and surface condition of the conductor. These all are affect the corona. Surface means smooth surface or hard surface. Okay, so methods of reducing the corona effect, it is by increasing the conductor size. Electric field around the conductor cause the corona, we know. Okay, hence to reduce the corona we should try to reduce the electrical field around the conductor surface, either by increasing the diameter of the conductor or arrange the conductor in set of 2, 3 and 4. We call it the bundling of the conductor. It means we can reduce the corona by increasing the diameter of the conductor, and we use the bundle conductor. Bundle conductor means it is the set of the 2 conductor, 3 conductor and 4 conductor. If we use the bundle conductor, we can reduce the corona effect. And using the hollow conductor, and next using the corona rings. We use corona rings because it reduces the electrical field intensity by giving a nice curvature shape at the sharp point. In this way, current does not be ionized the air. Okay, so but it flow through the corona ring. It cannot be ionized the air. This current is flow through the corona ring. So due to this we can reduce the corona, and by increasing the conductor spacing we can reduce the corona. Now, what is the critical disruptive voltage and what is the potential gradient? Okay, so when potential gradient we define, and we can say critical disruptive voltage and potential disruptive voltage also. When the potential disruptive voltage beyond the some threshold voltage, the threshold voltage means critical voltage. Okay, so this value, the field strength become strong enough for the air surround the conductor is dissociated into the ions making, and it conductive, and the critical distributed voltage occurs approximately 30 kilovolt. You can say here the formula for the critical disruptive voltage is Vc equal to m naught g naught delta r log E small d over small r into kV per phase. Here the delta is the air density factor and m naught is the irregulatory factor, 1 for polished conductor and 0.98 to 0.92 for dirty conductor and 0.87 to 0.8 for the standard conductor. Here V is the voltage applied and d, small d, is the distance between the voltage. Okay, and small r in the radius of the conductor. and G naught is the potential gradient. So visual critical voltage is denoted by mv into Z naught into delta R 1 plus 0.3 upon under root of delta into R into log E base D over R kilovolt per phase. So this is the minimum phase neutral voltage at which corona glow appears along the transmission line, and we can say along the conductor. Now the advantage of the conductor is, we have here some advantage of the corona. Due to corona, the electric static stress between the conductors is reduces, because due to corona formation the air surrounding the conductor become conducting, and hence a visual diameter of the conductor is increased, and the increase in diameter reduce the stress, electrostatic stress between the conductor. And corona reduce the effect of the transient produced by the surge. Effect of the transient produced by the lighting surge and other causes are reduced due to the corona. Charge induced on the line by the surge will be partially dissipate as the corona loss, and this is the way it act as a safety value. Okay, so disadvantage of the corona is, here due to this the efficiency, transmission efficiency is less, because there is a loss on the power. Corona loss is also called the power loss. So this is the loss on the power. So here this affect the transmission efficiency of the line. And ozone is produced by the corona, and it may cause the corrosion on the conductor due to the chemical reaction. And also here harmonics are reduced in the line, and during the formation of the corona ozone gas is formed, and this gas react with the material of the conductor, and this is caused the corrosion on the conductor. So these are the advantage and disadvantage of the corona. Thank you.